Greetings, pilgrims, and welcome to another episode of the Polygon Pilgrimage. And today we continue with our very exciting series here where we are creating some rolling dice. I want to pick up directly where we left off from last time. I did want to make a quick note that there were some audio issues with the previous episode, and I'm working hard to fix those. So I will be re-uploading that episode with proper audio and with a few extra steps in there, and we'll make sure that we get you all the way you need to be here for this episode today. So that episode may even already be up by the time you see this. So just know that I'm working hard to correct that. Now, today's episode would not be possible without the direct help with a great gentleman who is part of the Unreal community, and his name is Edward Gelbling. I hope I'm pronouncing that correct. Thank you, sir, for all of your assistance. He reached out to me and helped me very much with the dice here. We're actually going to be revamping our dice a little bit, and we're making them even better. So to begin, let's take a look at what we have. So if I hit play here, and I'm going to bring my mouse cursor up a little bit, we can push our die around, and it does roll. But you'll notice that it doesn't quite always land on a face. It'll land sometimes sort of in between two faces. And when we had that, we were looking at which of the faces would be most upright. But the problem is now you're looking at kind of in between two faces sometime. I really want it to land directly on a face always. So to fix that, we have to go back and redo a little bit of our previous work, but that's quite all right. So we're going to take our model here and we're going to take a look at it inside of Maya. So let's jump back to Maya and take a look at the changes we need to make. We'll jump back into Maya here, and here inside of Maya you can see our die, and it has some strange little markers floating around it. It might be a little difficult to see, but you can see them there, they're there floating around. So we're going to talk all about this. Now, back in Unreal, sorry, back and forth a little bit here, but if we look at our die, we can see what the problem is. So here's our model that we imported into Unreal, and the reason that it's not rolling quite right is because of its collision. So if I take a look at the collision, you'll see this is the collision, these lines here, that Unreal has generated for our die. And it's nowhere near correct to the actual shape of the die. As you can see, these strange approximations, it's trying to create this cage around our object. And while this does help it to roll, it does not help it to roll properly. It doesn't roll correctly. So that's what we need to fix. So we need to tell Unreal, you have to do better with your collisions. I want it to be precise because this shape is an exact shape. If you take a 12-sided die, 360 degrees divided by 12 is 30 degrees. So these are 30-degree faces here. And that should roll properly to the point that you have one of each of the faces facing upward when it lands. Now, because Unreal is not doing that, it doesn't roll correctly. Now, there is an option here in the settings. If I come down here, under Collision Complexity, you can select this Use Complex Collision as Simple. And voila, it's following the exact contours of the model. What this is doing is it's using the actual model as the collision, but it doesn't seem to work for physics very well. It just doesn't seem to treat it properly. In fact, it doesn't even react to physics at all when we do that. So that's not an option, so we need to find a way around that. And that's going to be what we're going to do inside of Maya. Okay? So let's jump over to Maya and take a look. Now, Edward sent me some information on the Unreal forums, and I read through it, and it explains that you can create a custom collision model and have that brought in along with your actual mesh, and then Unreal will treat that as the collision. Perfect. So what we're going to do is we're going to make a duplicate of this model here. So if I just select this, and here inside of Maya, if I use Control D, that makes a duplicate object, and I can move it along to the side. And you can see there, those are two directly identical models. Now this is just the model we made last time with the textures we made last time applied to it, so we can see them more accurately here, so we can tell which face is which. Now, as you can tell, I'm going to delete this here. In my outliner here, you can see that my model here, die_A, and then down here I have this strange object, and if I move it to the side, you'll notice it too is a direct duplicate of this. And that's exactly what we want. So this model will be my collision geometry, my custom collision that we will import. Now you'll notice it has a very specific name. Bring that up over here in the attribute editor. There we are. So its name is capital UCX underscore, and then the name of the model, so in this case, die underscore A, and then an underscore 01. The way that Unreal handles importing of meshes is you have the model itself, which the mesh as they call it, so die underscore A, and then if you have a custom collision, it must be named in this manner. UCX underscore, and then the mesh name, and then underscore, and it says numerically, but I've proven with the sockets you can even give them names, but they must be unique. Now the UCX stands for Unreal Concave Collision. So this is a concave shape, and then the X is for custom collision. Now the important thing is, if I undo a step here, let's see here. Let's undo, there we go. So that model must be directly over top of our model here. So you can see when I select between the two, nothing changes because they are exactly the same and they're in exactly the same place. So that handles for our custom collision. That means now our dice will roll absolutely physically properly, which is great. But now we need to do a little bit of work while we're here to create some way that we can tell what face is facing upward when the die finishes rolling. And that is handled with something called sockets. Now think of a socket as just an invisible pointer in the world. It's just a point in space that we can reference by name. And since it's a point in space, it has X, Y, and Z values. So the idea here is that we're going to roll this die, and then we're going to look through all 12 of these pointers that we're going to make. And we're going to say, get the Z value, the height of each of these points, and then tell me which point is the highest in the Z in the world. That has to be the face that's on top. So then that will tell us what face we've rolled on. And so we just have names for them here. As you can see, they're all named based upon their value. So it's going to be loot, skull, question mark, effect, and attack, I think. Yeah, those are the 4 there, or 5. So each of those around the face here, each socket is named, and then you can see we have numbers here: 1, 2, 3. If there's more than 2 on a die, the other die will be different. Eventually, we're going to have a different set of rolling, but it'll be the same faces here, the same possible symbols, just a different number and a different order of them. Okay, so how do we create these? So here inside of Maya, I'm going to go over here to create, and I'm going to say locator, and that's what these things are called inside of Maya. So I'm going to move this one aside, and the way that I created these, since we know that it's a 30-degree angle is what we're looking for, I went here and I said I'm going to move it forward a bit, and I'm going to go D on the keyboard to change my pivot, and I move the pivot back to the 0, 0 spot. And if I hit D again to get out of that mode, you can see now that if I rotate from that place, I'm rotating that locator, and I have it set to 30-degree increments right now. You might be able to see over here, this is changing, so that's -30, -60, 0, 30, and so forth. So once I had that set up and I had a correct distance that I liked, I just made sure they were off of the face just a little bit so that I was able to select them. Then it's just a matter of rotating in increments of 30, and I would do a shift, Control D, and then move these around, so something like that, say. Now I have 2 locators in space here by making a copy of the first, and these also have to be named appropriately for Unreal to be able to bring these in and know how to handle them. So the way these need to be named is, here we have one, and we'll look at this as an example. It has to be named all capital letters, socket, SOCKET underscore, and then the name of the mesh, so this is die underscore A, and then it has to be, their example shows that it is numerical, so 0, 1, 0, 2, 0, 3, etc. As an experiment, I gave them names, and it happened to work out quite nicely. So I gave them all names, and the names are based upon whichever face value they are closest to, obviously. So now, the last bit of information I have for you here about this is the selecting of your model here inside of Maya to export for this process is very specific. So I find it's easiest with the outliner open here. So I'm going to select the model itself first, and then I'm going to select the collision mesh second, and I'm going to do Control Shift here and drag and select all of the sockets all at once. Selecting them in that order seems to be very important from getting them outside of Maya and into Unreal. So with them selected in that order, we're going to go up here and say File, export selection. And when it comes up, we're going to tell it where, we're going to tell it what we want to call it. And over here, these are the three options that I have selected: smoothing groups, smooth mesh, and triangulate. And then you just say export, and we're all done. Now I'm not going to do that in this instance because I've already done it. But again, this is the same model from last time. Haven't made any other changes to it except to make a duplicate and to name them specifically, and then to create the locators. Okay, so with that done, we're done with Maya for now. Let's close that. And let's take a look at what that die looks like when we bring it into Unreal. So when you go right click, import, and then you point to your file. When you import your options there, what you're going to want to do is check, there's a little checkbox towards the bottom that says combine meshes. Make sure that is checked. And you can uncheck the auto generate collision because we're importing our own. Now, once that's imported, this is what it will look like. So here's our die, and you can see all these weird kind of wireframe looking, spindly looking things with text on them. And the text is directly related to the names of our sockets. And you'll notice down here in the bottom, this is our socket manager. And here's each of the sockets. And this will tell you about its relative rotation and its location. And so these are all based upon where I have them on the model. Very good. Now let's check our collision. So if I click up here to view collision, look at that. It's the exact shape of our die because it's using that collision mesh we imported. Now let's look at the settings for that. If we scroll down here, under collision, you'll see that under convex elements, there is one array in the elements, or an array of one element is really what that should say. And here you can see there's 0 members, there's that 0. So 0 is the first entry in an array. And it's block all, of course. If we scroll down a little bit further, you'll see here customized collision. That is checked. So that means that it brought in that custom collision mesh that we asked it to. And you might even be able to see, maybe not. In my other project, I think I saw a spot where it actually named the path to the file, so that way I knew it was exactly that. And then down here you'll see under mesh, the combined meshes. And that's what tells it, hey, I have more than one mesh, but each of these meshes, I want you to combine them all into one sort of model import. Okay, so that's all well and good, and we have a die that has the potential for information gathering. Now we have to go about actually doing that information gathering. So let's go back to our scene, and we're going to create a new blueprint. As you can see here, I've done it a few times, but I want to show you the actual setup. So I'm going to say right-click, blueprint. It's going to be an actor. I'm going to call it BP Tut Die. So tutorial die. Enter. And double-click that guy, and we'll bring him over here. Take a look at him. Okay, so right away, there's nothing here, and we need to have a model. So let's go up here to add component. And I'm going to add a static mesh. Let's call this die. And I'm going to click and drag and drop him to make him the new root. Now you'll notice there's nothing here now. That's because there is a static mesh here. We just haven't told Unreal what static mesh to use yet. So I'm going to click this drop down, and I'm going to select die_A. That's the one from our example, and there he is. You can see it fills in this, and it fills in our materials right away. So let's make some changes here. And I'm going to compare my notes from over here so we make sure we do it right. So we're going to check the simulate physics because we do want it to be a physics actor. We want it to actually have mass and interact with the world physically. Then, down here, let's make sure we're going to need to check this box. Simulation generates hit events. We're going to check that box because we're going to make a special little piece of code that will allow our dice to bounce off of anything that they should not be settling on. For example, you don't want the die to be able to settle on some stairs because now they'll settle with a face not being directly north, directly up, so that we can have an actual roll accomplished. So we need to say if you land on something like stairs or the lip of some sort of pillar or something, we want to make sure that it kind of bounces off a little bit and then it will resettle somewhere more appropriate, somewhere more flat like the floor. Okay, so it is a physics actor. That's all well and good. Then down here at the bottom, we need to check a couple of these plus boxes here for our events. And we want two in particular. We want on component hit, so I'm going to click this, and you'll notice it pops me right over to the event graph and adds this thing. Whoa there, Tiger. We're going to come back to this. I'm going to move this down. Go back to the viewport. There we go. Reselect our die. Okay, we're back to here. Now we also want to check this one that says on component sleep. So I'm going to click that. There we go. That's the one we really want. Okay. So now we're all done with everything here in the viewport for now. So let's go over to our event graph. Okay, now we're going to start doing some actual coding here. So the first thing we want to do is we need to create three things to help us with our decision making here. We need two variables, and we're going to create an event. Now let me, an event dispatcher, pardon me. Let me explain kind of what event dispatchers do. If you think of an event dispatcher, it's sort of like broadcasting a message, and then you have people who are listening for that message. This works very similar to the way you guys who watch the videos here, and thank you very much for being a subscriber, and if you're new, welcome. So if you're subscribed, whenever I put a video out, it sends you an email, or it lights up in your subscription box saying, hey, there's something new available for you. So that is an event that has been dispatched by me by putting the video out, and then you are on the receiving end, you are listening for that event and getting information from it. Hey, there's a new video available. So that's kind of the way it works here with scripting. So we're going to have an event that we call, and then later our dice manager is going to be looking or listening for those events to get that information. So let's start with that. We're going to create an event, and we're going to call this event dice have landed. Okay? That means that they are in their final resting position for now, and they have decided on what face to show. So now we need to give it two inputs, two bits of information we're going to give this event. So I'm going to click New, and we're going to call this first one Result. And this result is going to be of a type of name. So this is going to be the name, as you saw there from the sockets where it says Loot 1, Skull 1, whatever, that's going to be the name that we give it. Then I'm going to say New again. And this is going to be die ref. So this is a reference to the die that has been rolled. So we know which die it is. Now this is going to be a very specific type. So if you click this drop down, in the search here, we're going to search for our tutorial die here. So it's going to be BP underscore tut die right there. And we are going to do by reference. Okay? So let's say compile, save, always save for good measure. Now we need two variables. So the way that we talked about, the way we're going to do this is we have the die, we have all 12 of the different faces, and we're going to loop through them and count them all and say which one is highest in the Z value in the world. So we need a variable to tell us what is the highest value currently. So say variable, I'm going to call it highest, and this variable is going to be of a type float. Compile, save. Now our other variable is going to be the name that we're going to pass along. So what is the face that is showing? So here I'm going to say variable face showing, and that is going to be of a type name. Okay, save. There we go. So let's get started with the actual coding now. So from the on sleep, so sleep means that when the physics of an object has finished and it doesn't detect any more velocity at the moment, it has come to a rest. It has stopped rolling. So once that has happened, we need to do something. So the first thing we're going to do is we're going to set our variable for highest to a ridiculous number. Just going to bring this out and say set. And we are going to set this value to minus 9999. Okay? And the reason being is we're going to do this sort of, it's called bubble up in programming. I think of it more like king of the hill. So we're going to start with a very low value, because if the die happens to fall into like a little bit of a pit, or if you're building a level where it goes down instead of up or something, then we have this really, really low number. So that means that all of the 12 sides have to possibly be higher than this to start with. Otherwise, this method doesn't work. So now that we have a ridiculously low number, what we're going to do is we're going to loop through each of the faces on the die. And to do that, we need to get a reference to our die. And I'm going to drag off from this, and I'm going to say, get all socket names. Okay, so I'm going to get each of the sockets on all 12 faces. Now from here, I'm going to say, for each loop. So we're going to go through every single one of these. All right, so we're taking the die, we're getting all the names of the sockets, and we're going to loop through all of them, and there's only 12. So we have to know we go through all 12. So what is it we want to do with each one of these? We want to see if a certain condition is true. So I'm going to hold the B key and click, and I'm going to get a branch. So for the loop, I'm going to say each one, I want to do this. I want to check. And what I want to check is if the value in the Z is larger than this number. So I want to get that number, so I'm going to get a copy of that. And I want to do a comparison. So I'm going to say float greater than float. And I actually want this to be on this one. There we go. Now, what am I comparing this number to? I'm going to take the element of the array. So as we're looping through, we're looking at the first one, the second one, the third one. This is referencing that one, whichever one we're on. I'm going to say get socket location. Very cool. Okay, now we don't need two of these, so I'm going to delete this. And I like to reuse, so there we go. We're just targeting get the socket location. The socket's parent is the die itself. Now, I need to get a singular value here, a float value, and this is giving me a vector, which is actually 3 values. So what I'm going to do is I'm going to right click and say split struct pin. Boom. Now that gives me 3 individual floats. I only really want to focus on the Z value, so I'm going to click that over into here. So now this is comparing the height in the world on Z with this value of highest. So obviously, if this die is on the ground and the ground is 0, 0, then the smallest value that any of these can be is like maybe a negative 0.2. And so that's definitely a higher value than negative 9,999, right? So that first one is definitely going to be true if I connect this up. So it'll definitely be true and it will go through the loop. But now the next one that comes along is going to be slightly higher on the die, and its value is also going to be higher, so then it's also going to be true. And what we're going to do is each time it's true, we're going to set that value to the new highest. Okay, so you can see how we start to do that king of the hill. So that first value that was like the 0.2, that's highest, so it gets set. Then the next value is like a 0.6, that's highest, it gets set. So they keep kind of trumping each other, okay? Now, so we want to set that value to this Z value here. So I'm going to click that over there. There we go. So now if we've now found our highest value when we're all done, then we also want to set our face showing. So we're going to set that and say, okay, if this guy is the one who is king of the hill, then what is his name? And his name is going to come directly from here. There we go. So that's only once we've found our highest value. Compile, save. So now once we've found our highest value, then we're good. And now we just have to tell we have to send out that event. We say, okay, the dice have officially landed now, and here are the values that we want. So we're going to go over here to our for each loop. When we've completed, we've gone through all 12, what are we going to do? We're going to call dice have landed. We're going to call that event. And look at this. It's looking for a couple of things. It needs a reference to itself. It needs a die reference. And it needs to know what is the result, what is the face showing, okay? So die reference, well, we are the die. This information is inside of the die. So we can do this, but what we can do is a self reference. Self, get reference to self, because it is us. We are within the die. So there you go. Reference to self. Now the result is going to be this face showing. I'm going to get it, place that there. There we go. Okay, so that calls the function. That's all that does. Now, 2 other things that I wanted to do to make it for myself a little easier to tell when the die has officially landed. Let's give ourselves a visual indicator, and then I'm going to freeze the simulation so that way the die won't roll anymore once it's rolled, okay? And that's just for now. We're going to change that later on in the project. So we want to make sure that we have a visual indicator. So what we're going to do is we're actually going to spawn. Let's see, let's spawn in a particle system emitter at location. So if you just type spawn part, it knows you want particle system, spawn emitter at location. Okay. What kind of emitter do we want? Well, if I select from this list, the second one on the list is an explosion. It's a nice little to tell us that the die has rolled, but it needs a location. So that location we're going to get from the die itself, this reference to ourself, this die reference here. We'll bring this over and say get world. We're going to get our world transform, okay? And again, we're going to do our split trick here because we need to give it a location and a rotation. So if I right click here and say split struct, oh, look at this. I have a location and I have a rotation. So that means it will spawn at the die, okay? So compile and save. And one last thing, now that the die has officially landed and we've played our particle effect, we want to freeze the die in place. We don't want it to simulate anymore. So I'm going to drag off of this and say set simulation physics. There it is. And I need a target for this, and the target is, of course, the die. So let's drag that over. And now by leaving this box unchecked, that indicates it's a Boolean value. You see there, Boolean? So that's telling me that, okay, that's going to be false because it's empty. So that will turn off physics for this object. All right, so let's compile and save, and I'll show you what that looks like. So let me go to test here, and we're going to pull up our die A. I believe that's this guy here. Make sure we'll delete him, and we'll hit play. Boom, explosion, and he's no longer moving. Now you'll notice that he fell straight down and he landed right on the edge of himself, which is incorrect, and we're going to fix that in just a little bit. But if I play again, if I get a chance to bump into it before it settles, you'll see it will land properly. Land properly, and now I can't push him anymore. That's perfect. So that's what we got going on, and we will fix it landing directly on that line in just a moment. Okay. So that's good. We're all done with that. Now, one more thing we want to do is we want to make sure that the die will not land on those odd surfaces like I mentioned, right? So let's bring this down here, and we're going to do that next. Okay, so this says on component hit, it's going to get the thing that it hit, which in this case is the floor or anything else, right? So when we hit something, we want to make a decision. So let's do another branch. There we go. Now our condition is going to be based upon what we hit. So we're going to go here, other component. I'm going to drag out and say component. Whoops. Component has tag. Component has tag. There you go. So we're going to be looking to see if the thing we hit has a very specific tag associated with it. So we're going to drag that over there. And we're going to call this tag dice surface. Okay? So this will be an acceptable position for a die to land in the world. All right? So let's do that. Now, we need to make another decision. There we go. We're going to say that if we are currently simulating physics, then we're going to do this thing, because we turn off the physics if it stops rolling, okay? So we're going to say if we're currently simulating physics. So we're going to take a reference to our die, and I'm going to say is simulating physics. All right? If that is true, then we're going to move forward with doing what we're doing here. Because if it's not true, then we're not going to touch it. So out of our hit here, we're going to pull out a break hit result. And what all this means is, tell me more about exactly what I hit. Here's all the different things you can tell about the hit. What time you hit it, exactly where you hit it, what the normal is. Okay, so it's a lot of information, but basically just this is more information about the thing that I hit. all I really care about is this impact normal. That means the exact angle that I hit the thing at, the floor, the stairs, whatever. So I'm going to pull that out, and I'm going to say a vector times float, sorry. Vector times float, and we're going to give it a little bit of a push. So I'm going to give it a push of 10,000. Sounds like a lot, but in physics calculation here, it's not too bad. So then from here, all we're going to do is say, if it is true that we are currently simulating physics, and it is true that we have, oh, I'm sorry, this is false. Woo, I'm sorry about that. So if we have not landed on an appropriate surface, but it is true that we are simulating physics, so we're still moving. Okay, cool, let's go ahead and add a little bit of force. So add impulse. Okay, and again, it does that. I'll just reuse this. And we want to give it this impulse. So this impulse we're giving it, think of like Star Trek, impulse engines. Push us forward, right? We're going to push us forward based upon the angle that we hit the thing. All right, so let's go ahead and save. And again, back to our world here. Now, the floor here, I've already assigned dice surface as the tag, but watch what happens if I get rid of that. Okay, if I give it tag of none, and we hit save, this die is going to constantly bounce. If I give it just a little bit of a push, it's going to bounce forever. It'll go right off the board unless I stop it. Because it cannot settle because the thing it is bouncing on has been labeled as an inappropriate surface for it to land on. That's why it won't settle. So if I go here and I put that back and say dice surface, that tells it, hey, this floor is A-okay for you to land on. So now it will land. So that way, all we have to do is apply that one tag to one thing, to the floor. And everything else, we just don't put that tag on it, and it will not land on anything but the floor. Pretty cool, right? Okay. Last little bit, let's go ahead and make our dice manager. So what we're going to do is we're going to get rid of this die from the world, because we're going to actually make an object that is going to be in the world, doesn't matter where. You won't be able to see it. And what it's going to do is it's going to generate the dice for us. It will spawn them up in the air, they'll drop down, and then it will manage the dice, and it will tell us where and how they have landed. Well, it'll tell us how they've landed. So let me go ahead and add that to the world, and then I will explain how we create it. So there he is in the world, and now let's go ahead and take a look at how to make him. So we'll go into the tutorial here, and I'm going to say right-click, new blueprint. It's an actor. BP toot dice manage. Okay? Open that guy up. There he is. He's nothing. And we're not going to do anything else in here because he has no substance in the actual world. He's just here to do work. So, in his event graph, on event begin play, where you want to spawn some dice into the world. So I'm going to drag off of this and say spawn actor from class. Okay, so this means make something in the world. Okay, conjure it up. So I'm going to tell it what to choose. And I'm going to tell it to choose our tutorial dice here, BP toot dice. There it is, toot die. There it is. And again, there's this transform here, and I'm going to break that open. So split struct. This will tell me where and in what rotation I want. So I'm going to put it up in the air a little bit, 500. And the rotation, I'm going to give it 12 and 12. Just so that it has a little bit of a spin to it, and that way it won't fall directly down. Okay? Now from here, we need to bind this to our event. What that means is this is going to say, okay, so in doing this, I want you to call this event that we have set up already. So I'm going to say bind to event. Let's see, I think I can say bind to dice have landed. There you go. Okay, and what is it that is being bound? It's the return value from this. This die is calling this event. Now, you'll notice we have here this little thing that says event. So if I drag that off, I can say add event, add custom event. You can name this whatever you want. This is the actual thing that is doing the event event managing, and each of these are going to be pointing to this guy. And that's just kind of how it works. It's a little weird. I still have a little trouble with it, but we are spawning this thing and we're saying, hey, call this event because I've done this thing and this thing is managing these events. Okay? Now, we need 2 dice, not just 1. So, we can come off of here and say spawn actor from class. There we go. And again, we want to choose the die. So let's go down here, toot die. And again, I'm going to crack this open. And I'm going to give this a different, so 300, and this is going to be minus 12 and 12. Okay, just so it's a little different. And then from here, I'm going to say bind to dice have landed. All right, but this time I don't need to create a new event. We already have this one that can manage that because it's the same event. So this guy is managing these events. And you notice this says result and die ref because those are the 2 inputs we gave. Now this event is giving us the outputs. So now this thing can be calling this event and say, here are the things that I'm getting from that event. Now we can do stuff with those things. In this case, what we're going to do is we're going to look at those and say, let's print those to the screen. Again, let's link these up because this guy is calling this event by being spawned. All right, let's bring this down to just ease of use. Now that everything is done, we can do something. And that thing that we're going to do is print things to the screen. So here I'm going to drag this out and say print. Okay. And first thing I'm going to drag over is the result. And here you say it says it's going to convert name to string. So that's what this is. Because this is a name variable, but this is a string. And then we're going to just concatenate this with print. Well, not concatenate, but it's going to do a secondary print. The die reference will tell us, get the name of the thing that was referenced. So this will call for both dice. See 2 of these lines. So it'll say, hey, when this event is called, manage that event and do this with that information. And hey, then we go down the line and say, oh, we spawned a second die. And hey, manage this event for me too. Do the same kind of thing. Okay, so let's save. And now if we jump into the world, let's take a look. So if I hit play and pull back on the thing, right away let's try and, oh, come on. Let's push them around a little bit. And when they settle, boom, and look in the upper left. It will tell me what the die is and what it landed on. So if I kind of bump them a little bit just so that we make sure it's a random number. There we go. So that's effect and die A. Okay, let's try it one more time. Just try and get a different roll. So skull and then attack. Yep. So it's telling me exactly what these dice have rolled. So now I know that computationally. I don't have to worry about how that is handled visually. We don't have to look at it any other way. We know computationally how that's happening. So there you go. We have our custom rolling dice. We have dice that know what they've rolled. We have a management system to reach in and do things with that. So now if you roll a skull and a sword, then I can say, okay, well that means that we're going to do some kind of damage to every enemy, or every enemy will now do double damage for a short time. Some kind of effect. That's what we're going for the overall game. So I hope you guys have enjoyed very much. And I know this has been a little complex, but we did some really excellent work here. And everything is looking nice and working well. And next time we're going to be working with more of the environment. And we'll come back to the dice later once I've decided what those different effects are going to be and how those work with the world. And we'll be picking up the dice and throwing them at our enemies, doing damage to them, but then it also rolls the die. So now you, pun intended, you have to roll the dice and see what it's going to do for the world here and make changes to the game board, changes to the rules. So I hope that you guys have enjoyed very much. Thank you so much for your time and attention. And as always, guys, keep practicing, get better, and I'll see you next time as the pilgrimage continues.